Hello, and welcome back to Data Literacy and Data Visualization. I'm Professor Braumoller. In this lecture, we're going to talk about a kind of a natural experiment called a regression discontinuity design. Now, it can be a little bit daunting to talk about this particular kind of research design in a class that doesn't involve statistics, because the way that it's usually discussed and conceived of in the literature is fairly statistical, and it revolves around a statistical technique called regression, which we aren't going to be learning here. But that's actually not as important as it might seem, and I'll explain why. Really, what it's all about is looking for the discontinuity, which is, as you can see in this diagram, a break between a control group and a treatment group that shows up as significant on a plot. Now, what is a regression discontinuity design? It's a natural experiment in which you've got the treatment applied at or above some cutoff point, and that was the dashed line that we saw in the diagram in the previous slide, and one in which, if the treatment actually has an effect, you'll see that effect in a difference between the average values of the observations just above that point and the average values of the observations just below that point. Okay? So the terminology, as I mentioned a moment ago, comes from a statistical procedure called regression. Now, as I said, you're not going to learn that here. You can use the lowest command in R to estimate and draw lines among data like this, so you can get some visual sense of how big the difference is. And later on we'll talk about how to measure the difference between see whether or not the difference between the points adjacent to the line on the other side is plausibly the result of random chance. So you don't really need to understand regression in order to understand the regression discontinuity design. Now, the discontinuity really is the big deal. It's the break that separates the treatment from the control group. So how is it that, when would you expect to see a situation where a regression discontinuity design is an appropriate research design? Well, if you find situations in which there's some sort of continuous relationship with an arbitrary cutoff that is applied consistently. Let's say you're looking at a university that issues scholarships to any incoming student, high school student with a grade point average above 3.8, but doesn't issue them to students with a 3.7999, right? And you want to understand what the impact of getting a scholarship is. Well, the folks with 3.75 to 3.8 GPAs are probably a lot like the folks with 3.8 to 3.85 GPAs, except that the second group got scholarships and the first group didn't. So one research design you might consider, if you're trying to estimate the impact of receiving a scholarship, is to compare outcomes, GPA in college, career outcomes, whatever you're interested in down the line, between the 3.75 to 3.8 group and the 3.8 to 3.85 group. And what makes that possible is that consistent cutoff in the application of the scholarship. Another possibility, which we discussed toward the end of the previous lecture, is boundaries that are drawn arbitrarily. So sometimes school districts will draw boundaries down the middle of a street. Sometimes there are arbitrary borders between states or counties, between different countries, that sort of thing. Another possibility, we'll give examples of all of these down the line, are focal points, that is, discrete points on a continuum that strike people as being natural focal points, or naturally salient or relevant. Okay? So let's take a look at the effects of cutoffs. This is an interesting study in the Journal of Econometrics about the incumbency advantage in the U.S. House when it comes to subsequent elections. Now, the intuition here is that you can actually predict the probability of winning an election 2 years from now by using the margin of victory in the current election. And you look for a discontinuity at zero margin of victory in this election. So the intuition behind this is that you're going to have candidates of varying quality, and the candidates of better quality are the ones who are more likely to be elected. But the ones who are right around 0.5 vote turnout, that is, people who just barely lost an election, are probably candidates who are just about as good as those candidates who barely won. Now, if winning the election this year had no impact on the probability of winning the election 2 years down the line, you wouldn't see any difference between those two groups, right? The folks who got 49% of the vote this year, 2 years down the line they'd run again, and they'd have a pretty good chance of winning, right? Because the 49% was awfully close. And the people who got 51%, if there's no incumbent advantage, wouldn't necessarily have the greatest chance of winning the election. So there shouldn't be much difference if there's no advantage whatsoever to incumbency. Well, when you take a look at the data, you see something completely different, right? Now, the data and the line are derived from another statistical model we won't talk about, logit analysis. And all of these, by the way, are really good reasons to take a class in statistics because they're very handy techniques to have under your belt. Again, we don't need to understand them here. What we do need to understand is that in this case, a logit analysis is simply a way of estimating the underlying probability of winning an election in the next, in 2 years down the line. So what you see is there's a huge discontinuity, right? There's a really big jump. The probability of winning the next election increases by almost 50% for borderline candidates who won this election. That's a really big effect, right? So this is a really handy way of showing that whether or not you win this election has a huge impact on whether or not you win the subsequent election, right? So it's a really handy way of gauging the magnitude of the incumbency advantage. Next, I want to take a look at the impact of historical borders. This is a really neat piece. Grossfield and Zhuravskaya, 2013, take a look at the what they call the persistent effects of empires. Now, they look at borders that were implemented in the 1700s in a country, Poland, that was eliminated in the 1700s but then resurrected in 1918, and they ask, did those pre-1918 partitions, did the partitions of Poland that survived until 1918 have a lasting effect on opinion in Poland today? So if we take a look at these borders, you can see on the eastern side the lighter to darker green regions are the ones that were absorbed by Russia. On the western side, the blue regions are the ones that were absorbed by Prussia. And then toward the south, the brighter green, sort of more yellowish green regions are the ones that were absorbed by Austria. And they were absorbed in 3 separate partitions of Poland, culminating in 1795. So what these researchers did was they took a look at modern Poland, and they took a look at the opinions of citizens of Poland based on correlated them with how far away they are from the previous borders of the different empires to see whether there were any discontinuities. So you got results like this one, right? When you ask them, do you prefer democracy? You see that the Russia-Austria border is a very salient one. People who are just on the Austria side of the Austria border are much more likely to prefer democracy than people who are just on the Russia side of the Russia-Austria border. Similarly, if you look at the percentage of people who are attending Mass every week, you find that the folks just on the Russia side of what used to be the Russia-Prussia border are considerably less likely to attend Mass every week than the folks who are just on the Prussia side of the former Russia-Prussia border. Now, recall that this is well over let's see, now we're a couple hundred years after these partitions were implemented, and more than a century after they disappeared. So it's really striking to see the impact of these borders so many decades after they disappeared. This is another great opportunity, this particular study, for mapping, because you can use choropleth maps to get a sense of what opinions are. This is vote for liberal parties in Poland, and you can see when you draw the former boundaries of the empires, you can see that there really are significant breaks from one region to the next in terms of vote. So it's a striking example of taking a look at at discontinuities based on borders that were implemented many years ago and disappeared many years ago on public opinion today. And it's kind of a neat, when you think about it, the way that public opinion is portrayed in the media is so volatile, right? I mean, when we're going up to an election, people really, the journalists really give the impression that public opinion can be swayed one way or another by something that this candidate said something outrageous, public opinion reacts in a certain way, that sort of thing. And it gives you the impression that every day's news has an impact on public opinion. But when you look at a study like this and you realize how lasting differences can be based on the countries that people used to live in this instance, it gives you it gives you a very different opinion about a different view of public opinion as being much more lasting and durable than what you probably get from news reports. All right, another example, used car prices. This is a fun example because the pattern, you take a look at the data and the pattern just pop right out. This is a study from the American Economic Review on what they call heuristic thinking and limited attention in the car market. Now, the used car market is a great example of a situation in which lots and lots of information is readily available. You can get a Carfax information about an automobile. You can get its accident history. You can get its maintenance history. There's lots of information out there to use to gauge what the value of the car is. But people do tend to look at mileage, and there are salient points when it comes to mileage. If a car has less than 100,000 miles, that's different than if it has more than 100,000 miles, right? So what they did was they took a look at average used car sales prices as a function of mileage, and this graph popped out where you can see all of the discontinuities along its salient mileage points, 10,000, 20,000, 30,000, 40,000, so on and so forth. So the lesson here is if you're going to sell your used car, sell it at 99,999 miles instead of 10,001, because the price you get for it will be actually substantially different. And retailers have absorbed this lesson for many years. That's why things are sold at $9.99 rather than $10. So here's the upshot. Regression discontinuity designs can be a really compelling form of a natural experiment, especially when you're looking at a cutoff or a border that's really coherent. They give you the opportunity to study groups that are very similar in other ways, except for their position relative to that cutoff. As we've seen here, for a class on data visualization, it's an especially nice research design because there are so many opportunities to visualize the results in really compelling ways. Now, that said, it's still difficult at this point in the class, we still don't have any tools that would allow us to test the hypothesis that this discontinuity is just due to random chance. And in order to make a compelling case in a regression discontinuity design, you either need a big discontinuity like the one in the incumbency advantage piece, or you need to have some test that will allow you to assess the hypothesis that this discontinuity is due to chance. We will have those tools in a few lectures on down the line When we talk about Monte Carlo tests, we don't currently have them.